this tutorial will help you to complete the questions on homework number 10. Let's take a look at the first topic, linear inequality and number line level 2. So in this task, you need to solve the inequality, and then you can graph that inequality on the number line. So when you're solving the inequality here, right, what we're going to do is we are going to use our inverse properties of equality to clear our constant, and then division property of equality to isolate our variable by clearing the coefficient. So our inequality is that x is less than 1. So that's what we're going to type here in the inequality notation box. Type an x, click this less than sign, and then type a 1. Next, you're going to move down to this number line, and you're going to click on this value. So for us it's 1, and then while you hold your mouse button down, you need to drag your finger in the lower than or less than direction all the way until you get to the edge of the graph when the green arrow appears. Next, you have to choose whether you want to keep a solid circle here, that's called a closed circle, or click it to create an open circle. So since we have a less than and not a less than or equal to, we cannot be equal to 1. So we're going to leave that circle open. And that is how you solve and graph on a number line. Again, use your properties of equality here, add 2 to both sides, divide both sides by 8, type your inequality here, and then click once with your mouse and drag it in the direction of your inequality symbol. Then choose whether you want an open or closed circle. Let's go to the next topic, number lines and interval notation. Remember, interval notation is the use of parentheses or brackets. Parentheses are used when you have a greater than or less than symbol, and brackets are used when you have a greater than or less than or equal to symbol. Now you can have lots of different combinations. You can have 2 parentheses, you can have 2 brackets, or you can have 1 parentheses and 1 bracket, or 1 bracket and 1 parentheses. Also note that infinity is not a value, so whether you have positive or negative infinity, it always gets parentheses. All right, let's take a look here. Notice we have a parentheses on the negative infinity value and a 0 on the right-hand side. So what that means is that our lowest value is negative infinity, and our highest value is 0. So that means that's as high as we can go. We cannot go past it. We cannot go past it. So 0 is where we're going to stop today. And the question is, when you stop on 0, should you be open or closed? And this symbol tells you you should be equal to, possibly, so you're going to be shaded in or closed. So we're going to shade in that circle here. And then once we're done shading in that circle, we're going to draw our arrow to the left. Right? So I'm going to do that now with the actual delta math. So I'm going to click on the 0 and drag my finger to the left until that arrow appears. Now the 0 should be shaded because you have a bracket. The parentheses would be open, but since it's infinity, that's an arrow. Infinity means you keep on going. It is not a number. So let's try this again. Express the interval shown on the number line using interval notation. So now we need to look at our lowest number and our highest number. And what we want to do is look at their circles. If they are open, like these are, meaning they are not filled in, then you need parentheses. So our lowest number needs a parentheses, and our highest number needs a parentheses. So I'm going to choose the one that has a pair of 2 parentheses. Once I click it, I will enter my lowest value first, which is -10, Then I will arrow to the right, so I'm on the other side of the comma, and my highest value is -8. Now if you forget to arrow to the right, your comma is going to be in the wrong place. So be careful. The comma should separate the two values. Let's try this one more time. -9, 4. So -9 is my lowest value. So I'm going to click here one time. I'm going to drag it, but this time I'm going to stop at +4. Now notice there's a bracket next to -9, so that means I can be equal to it, so solid. There's a bracket next to 4, I can be equal to it, so I'll keep it solid. Let's try one more. This one is going in opposite directions, so I actually need two different answers. I am either lower than or equal to -4, or I am 6 or greater than it. Now it does say express it using interval notation. So I'm going to clear this word or out. I'm going to go to my lowest value first, which is an arrow. My lowest value here is pointing in the negative direction, so that means -infinity. And in -infinity is always parentheses. Now, when I read to the right, my highest value would be -4. And so I have parentheses for my infinity, but I have a bracket because the 4 is solid. So I need a parentheses and then a bracket, which is this one here. -infinity, arrow over to the right, and then -4. I'm going to type on my keyboard. Now I'm going to get out of this interval notation. I'm going to click the word or, because I can either be in this green section or I can be in that green section, which starts at 6, which is a bracket, and continues through this arrow, which is infinity, which is parentheses. So I need a bracket and parentheses, which is this one. So starts at 6 and ends at infinity. One last time. See this symbol? Okay. See this symbol here? That means I am combining or joining this into a union. So -infinity to -4. So -infinity is my lowest, -4 is my highest. So I'm going to start at -4 and draw my arrow to -infinity. Now the -4 has a parentheses, so I'm going to open it. Now the union is a joining of either this one or that one. So it starts at 5. Click once, drag your arrow towards infinity. The 5 has a parentheses, so I'm going to open that circle. And there is my union. All right, let's take a look at the third one. Express the interval notation using inequality notation. So let's see what we've got here. We've got -8, -infinity, right? -infinity. Oops. So we've got -infinity to 3. So if I'm 3, I would be solid and then -infinity. And I also have 6 to +infinity. So 6, solid, and to +infinity. All right, so that's my picture, but what they want is inequality notation. So that when we join these things together using my union symbol. So I have anything with an infinity sign gets only one of these symbols. So I'm either 3 or I am less than it. So that means that x is less than 3. And this one over here, oops, less than or equal to, sorry, because it's solid. X is less than or equal to. And this one here says x can be greater than or equal to 6. So I can't be in both of these arrows. So I'm going to use the word or. I can either be less than or equal to 3, or I can be greater than or equal to 6. So x can be less than or equal to 3. Whoops, why did it say v? Or, click that word or, x can be greater than or equal to 6. Let's try this again. Now this one is just a single interval. So when you have a single interval, right, you are pointing at each other. This one's going that way, this one's going this way, and you have a joint drawing like this. So for us, we're going to start at 8, and we're going to go all the way to 11, or everything in between. So x is going to be in between our symbols. And the clue is that the symbols will always be less than or less than or equal to. When you are in between something, you're going to have two less than signs. So I can have two less than signs like this, or I can have one with a less than or equal to, or I can have both with less than or equal to, but it depends on whether you have parentheses or brackets. We've got two brackets, so that means I need two less than or equal to signs with an x in the middle. So x is between 8 and 11. X can be anything in between 8 and 11, and it could even be 8 or 11. That's why we put the equal to signs. Alright, so this is an in-between. X can be in between 2 and infinity. So I can use these two symbols, but this is a bracket, so I know that I need a greater, less than, this number is less than or equal to, so x is in between 2 and infinity. This is one way you could write it. But when you have a drawing like this, which is what you would have here, you could be equal to 2 or greater than. We don't generally use this combination when we write an inequality. We just say, well, you can be greater than or equal to 2. We don't say that you're between 2 and infinity. We just say you're greater than or equal to 2. So I can leave this here, but I'm actually going to simplify it just to say that x can be greater than or equal to 2. Right? Okay. Inequality notation and interval notation. So now they want you to express using inequality notation, which is what we were just practicing. So I can be -3 to infinity. So x can be anything that is greater than or equal to 3. Why am I using a greater than or equal to? Because it's a bracket, and because I can go all the way to positive infinity. So I can be greater than -3. Sorry, -3. Oh, I'm in the same... Sorry. All right. Express the interval using two different representations. So they want you to practice going back and forth now, the inequality and the graph. I feel like the graph is the easiest, so I'm going to start at -7. I'm going to go up to 11. I've got two parentheses, so I've got two open circles. And when I do that, I know I've got an in-between, right? So I know I need two of these, and I need an x in between. Now let's decide. Should any of these have equal to signs? No, because they're both open. So I put my -7 on the left and my 11 on the right. Because I'm between -7 and 11. I am in between -7 and 11. Why are these less than signs? Because these are parentheses. And you always use the less than symbol here when you are in between. Alright, so this one is either or. So x is less than 3. So let's go down here to the graph. Let's type a 3 and go less than. Equal to, less than or equal to, so solid. X is greater than or equal to 8, so solid. And now we're going to use interval notation. So we can say an arrow means parentheses, solid circle means bracket, parentheses and bracket. That's this one. So -infinity, arrow over the comma to 3. We're going to combine that, union that with bracket and parentheses, because here is 8 and there is infinity. Infinity always gets a parentheses. And we're using that union symbol because we're doing interval notation. If we were doing inequality notation, we use the word or. Interval notation, we use the U, the unit. All right, let's take a look at this compound here. And I am in between 5 and 10. I'm in between 5 and 10, and both my circles are open. So I'm going to go with 2 parentheses, and my lowest value is 5, my highest value is 10. And then when you are in between, you need 2 less than signs with an X in the middle. And then you decide, should I change any of these to less than or equal to's? Well, that depends. Do you have any solid circles? No. So let's leave them the same. Just copy the lowest number 5 and the highest number 10. Let's try one more. All right, they gave it to us in interval notation. I'm going to graph this. So between 4 and 7, and parentheses on the left, and parentheses on the right. So I got 2 open circles. When you are in between, remember you need 2 less than signs with an X in between. Now look to your circles. Are they solid or open? Both of them are open, so I do not need to change them to less than or equal to's. Put a 4 here and a 7 there. All right, next topic, justify the solution. So this one requires you to do a little bit of work. Let's see if we can't solve this problem here. Well, it can't have any denominators, so I'm going to multiply both sides by x, and I'm going to get 14 is equal to 2x, and divide both sides by 2, and I get 7 is equal to x. So that has a solution. So select an option that has one solution. The value of x that makes it true is 7, because I just did that. And when you put a 7 in, 2 is equal to 2. Now here is the hard part. All they want you to do is pick a wrong number. Pick any value of x that makes the equation false, means pick any number that's not a 7. So I'll pick something that I can divide 14 by, so I'll pick 1. If I plug a 1 into x, I would get a statement that said 14 was equal to 2. That's not true. All right, let's take a look at another problem. I got to do some math here. Again, I'm going to multiply both sides by x. And that would give me 39 is equal to 3x. Divide both sides by 3. And I'm going to get 13 is equal to x. 13 is equal to x. So you need some scrap paper. You realize this has one solution. And the solution is 3. And when I do that, 13 will be equal to 13. And now I make up any other number. I'm going to plug in a 1. Because 39 divided by 1 is 39. 39 is not equal to 13. All right, let's try another one. This is the same looking problem. So let me see if I can get a new, here we go. Okay, select an option. Well, let's do a little bit of math first. X plus x is 2x. So 2x equals 2x. You see it? Do you remember the answer? When the left side and the right side are a perfect match, we can say that it has infinite solutions. And then they ask you to choose a number that would make it true. So I'm going to plug in a 1 here. Because 1 plus 1 is 2, and 2 times 1 is 2. I'm plugging in a totally different number here, maybe 5. 5 plus 5 is 10, and 2 times 5 is 10. So 10 is equal to 10. And there's the proof. So you've got to solve the equation so you can determine how many solutions there are. All right, let's take a look at these fractions. Some of you are getting pretty good at these. So you're going to want to look at the denominators, 3 and 2, and these guys have denominators as well, don't forget. So the least common multiple would be 6, so I'm going to multiply each term by 6. Each term. Right, so over here I'm going to get a 6x plus 12. Over here I'm going to divide first, so that when I distribute here, I get the right values, and that's positive 3. X and positive 3. I'm going to combine like terms. And then I'm going to subtract. No, I'm not. I'm going to subtract 5x because I like to keep my x positive. And you know what? In the same move, I'm going to subtract 12. And when I do that, I know I've done it right because I've got a cancellation on both sides. And that leaves me with -1 is equal to x. So x is equal to -1. Let's take a look here. -1, see how we did. Let's try. Alright, let's take a look at these equations with fractions. I've got a denominator of 18 and 2, and don't forget he's got a denominator of 1. I'm going to multiply each term by 18, and that will give me a 1 here when I divide first, 9 here, and that will give me 2x minus 5 plus 9 times 9 is 81. And then 4 times 18 is 72. Combine like terms. Subtract 76. -4, divide by 2. And I get -2. Let's go back and type that in here, see how we do. Let's try another one. I'm going to screenshot this to make it easier to work with. Alright, I think I'm going to multiply by 20. And that's nice here because then I don't have to distribute anything. So I'm going to get -35 plus 8 equals 2x plus 3. I'm going to do two things at once here. Let's see. I'll combine like terms. -27 equals 2x plus 3. Subtract 3. -30 equals 2x. So x is -15. Let's type that in here. Let's see if I can't get one that looked like a little bit different. Yeah, this one. This will be a good one to try. My marker's acting funny, so I'm going to use this here. Now let's see, I've got 3 at 24. Oh, I'm going to multiply everybody by 24. Even these guys over here. So this side would be a 24x minus 24. And these here I'm going to divide first. And I'm going to distribute that 8. So 24x minus 16. And this one nothing to distribute. And I'm going to combine like terms. 27x. I think that's a minus and a minus, so 21. I'm going to do two steps at once here. I'm going to subtract 24x from each side, and I'm going to add 21 on each side, and that does give me that nice double cross off, right? So let's see, 3x equals -3. So x is equal to -1. Okay. That concludes our practice for homework number 10.